Alright, in today's lesson we're going to learn how to identify special quadrilaterals. We've learned about a lot of shapes so far. We've learned squares, rectangles, parallelograms. We've learned trapezoids, isosceles trapezoids, kites. So we've dealt with a lot of different types of quadrilaterals. And we're now going to be focusing on their key properties to be able to tell them apart. So today, let's focus on example 1. Here's a basic question you should be able to do. The first one says, quadrilateral ABCD has both pairs of opposite sides congruent. So maybe make a sketch of that. Opposite sides congruent. Well, a lot of times we saw it like this in the beginning. Sometimes we saw it a little more like this. What's the main difference between these two figures? Okay, the angles. They kind of look like 90s. We don't know if they're 90s yet. But what types of shapes do have this property of both pair of opposite sides congruent? Okay, parallelogram, rectangle, more, rhombus, square. Any others? It could be any of those shapes. So what types of shapes could it be if it has both pairs of opposite sides congruent? Any of those 4. Kite doesn't exactly have opposite sides congruent. So look at this. Here's an opposite side, and here's an opposite side. Are they congruent? Opposite sides are not congruent on a kite, so a kite would not work. Try checkpoint number 1 and see what you can come up with. All right. The key thing to help you on this is to be able to picture these shapes in your head. Maybe let's start with the square. If we start with the square, it has 90, so we're focused on angles. Are both pairs of opposite angles congruent? Are these congruent and those? Yes, so a square works. So this is what I picture in my head. I picture these shapes. Let's look at a rectangle. We know its angles. Does it have the same property? Opposite angles congruent? Definitely. So rectangle also works. What's another shape I could look at? Maybe a rhombus. So we know rhombus has all equal sides, but its angles. That one's obtuse. This one's the same. And these are the same. Opposite angles are congruent. Yep, rhombus works. Anything else? Parallelogram. And it also has that property. On example 2, it says, what's the most specific name you can give for that shape? What's the most specific name you can give for that shape? Well, first off, here's what you need to be able to do. Identify the property that's being displayed in that picture. What property is being demonstrated? All sides are congruent. All sides are congruent. That's the property that's being displayed. What's the number 1 shape with that property? Well, there are actually two shapes that have that property. I've heard these words, square and a rhombus. So you need to think which figure best displays that property, or which figure displayed that property first. Rhombus was the first shape we learned about that has that property. Square has other stuff. Rhombus, that's its basic definition. So a square does have it, but it's not as good as a rhombus. How do I know it's not a square? It kind of looks like it. Doesn't give you the angles, so don't start guessing on angles. Best answer here is rhombus. On example 3, it says, is there enough information given to say this is an isosceles trapezoid and explain. What did we learn yesterday about isosceles trapezoids? Yeah. Legs are equal. What did we learn about angles, though? Base angles are congruent, and the angles along the legs are supplementary. Two key facts. So write that down over here. Here's the key properties you should remember. For an isosceles trapezoid, you should remember that the base angles are congruent, and you should remember angles on the legs are supplementary. Those are two things we should check. We're missing an angle right now, but we know how to find the missing angle on a quadrilateral. What do? Okay, subtract these from 360. So 360 minus 102 minus 102 minus 78, and you get 78. So that missing angle is 78. All right, so we can figure that one out, and now we can think back over here. Are the base angles congruent? Well, this looks to be a base, and this looks to be a base. Congruent angles, looks good so far. The other thing I need to check, are the angles on the legs supplementary? So that's these two angles. Are those supplementary? Do these add to 180? Yes. And do these angles add to 180? Yes. So what are the reasons for an isosceles trapezoid? They're right here. Yes is an isosceles trapezoid because of these two reasons. That's your explanation, and here's your proof on that missing angle as well. Try out these next two checkpoints and see if you can finish those on your own. In checkpoint number 2, it says, what's the most specific name for that shape, and explain. I saw a lot of you put kite, and you were correct. But the reason why is what I'm really looking for. What was the reason why that's a kite? Okay, it's because the consecutive sides are congruent. And the other day we said two sets of consecutive sides are congruent, meaning these two are congruent and these two are congruent. So they're side by side instead of being opposite like we're used to seeing. Number 3, can we say that this shape is a rectangle? Yes, no, why? It is a yes, but my big problem is with the why. The why. Jordan, why? Sum is 360, so we can do 360 minus those 90s. Yep. Yep, that'd be a 90 then. So we just proved that that's a 90. But that's not really an explanation yet. Yes. More specific than all angles are congruent. It is true to say that all angles are congruent. They're all right angles. All 4 angles are right angles. All 4 angles are right angles. And that is the number 1 property on a rectangle. All 4 angles are right angles. Yes. The last thing we're going to do today is talk about some key vocab words. So the first one we're going to talk about is diagonal. So it says, give an example of a diagonal. So here's an example. If we have this shape, how many diagonals do we have? 2. Another way we saw it was if we had something like a pentagon, and I said how many diagonals can be drawn from one vertex? 1, 2. From one vertex, we only have 2. But if you're looking at all vertices, you have 3, 4, 5 total. So it depends on if it's saying from one vertex or from multiple vertices. Next good word to be able to do would be, what's a parallelogram? Okay, so parallelogram. Basic picture we drew in the past was like this. That's a basic picture of it. But what was its number one property? Parallel sides. Opposite sides are parallel. That was its number one property. Opposite sides are parallel. I'm just going to focus on the number, the most specific, the best property you could give for that shape. Obviously, there are a lot of others. Opposite angles are congruent, opposite sides are congruent, diagonals bisect each other. There's a lot more I could say, but I'm going to focus on the number one properties. Up next, we have rhombus. So we'll go to a rhombus next. What was the number one property on a rhombus? All sides are congruent. 4 congruent sides. It has 4 congruent sides. All sides are congruent. After we learned rhombus, we learned a rectangle. We've talked about that a lot today. What was the number one property on a rectangle? 4 right angles. All right, doing well. After rectangle, we had square. Square was kind of like a rhombus and a rectangle because it shared properties from both of those shapes. Square had what 2 properties? 4 right angles and 4 congruent sides. So 4 right angles, 4 congruent sides. Remember, these are just the basic properties of each of the shapes. They have a whole lot more than that, just we're focusing on the basics right now. Let's see, after that, what do we have? Oh, we had trapezoid. So trapezoid's up next. Trapezoid started looking a little different from the rest. Something like that, in which we had this drawn on it. What's that mean? One set of opposite sides parallel. One pair of opposite sides parallel. Only one pair. Then we got a little more specific. We started talking about another shape related to that trapezoid. What was that other shape? Yeah, it's kind of related to this one, the isosceles trapezoid. So that one looked a little bit nicer. Not only did it have one pair of opposite sides parallel, but it had what? 2 congruent legs. So legs are congruent and one pair. One pair of opposite sides congruent. Now we learned some other key parts on trapezoids. We learned that these parallel pieces are the bases. These are the bases, base 1, base 2. We learned that these other pieces are the legs. And we also learned about its angles. One other key property about its angles were that the base angles, so like these are 2 angles along this base, they're congruent, and 2 angles along this base are congruent. So you could also add base angles are congruent. One thing I wrote wrong, I wrote one pair of opposite sides are congruent. These are not congruent. These kind of legs are opposite and congruent, but I really meant to say one pair of opposite sides are parallel. That's the better property displayed on a basic isosceles trapezoid. Up next we had mid-segment of a trapezoid. So mid-segment of trapezoid. I like this one because I think it's simple math. Whenever you have a trapezoid, it has two parallel sides. If you draw the midpoints on these legs and connect them, you've created the mid-segment. So this piece right here in red is the mid-segment. Mid-segment has some nice simple math. If this piece is 12, this piece is 10, how long is the shorter base? 8. So there's some simple math to do that. How'd I go from 12 to 10? Subtracted 2, 10 to 8, subtract 2 as well. You could also find the middle piece by doing 8 plus 12 is 10. So that's another good piece of math. 8 plus 12 divided by 2 is 10. We had one last shape, and it's kind of the oddball. It's a kite. So there's a kite. We learned a few different things about it. What was its number one property? Consecutive sides are congruent. So that means these are side by side and congruent. These sides are congruent as well. They're side by side. It has two sets of those. We learned a little bit more that I don't mind to add. Does anybody remember any other key properties? Okay, only one pair of opposite angles congruent. So only one pair of opposite angles congruent. Good job. There's one other thing we said about it. Diagonals are perpendicular. Awesome. So diagonals came down through here. They're perpendicular. Diagonals are perpendicular.